For this review problem, we're going to prove that if n is an integer and n is an even integer, then n is not also simultaneously an odd integer. Now this seems obvious that no number is both odd and even. We're going to prove this using the formal definitions of odd and even. So the proof of this is actually going to be by contradiction. Now for a proof by contradiction, we assume the hypothesis, we assume the negation of the conclusion, and we'll somehow show that something goes wrong. So first we assume the hypothesis. Let n be an even integer. Then by definition, there is an integer k so that n is equal to 2 times k. So we assume the hypothesis. We now assume, for the sake of contradiction, the negation of the conclusion. So suppose, and I'll mark parenthetically for the sake of contradiction, so for argument's sake, that the negation of the conclusion. Well, the negation of n being not odd is that n is odd. If n is odd, by definition, there is an integer j so that n is equal to 2j plus 1 because n is odd. Now notice that I chose a different letter because the letter k has already been used. So n is equal to 2 times k, and so I must use some different letter for this one. Okay, now I have to use these two assumptions and so show that something goes wrong. So if n equals 2 times k and n equals 2j plus 1, then I can set them equal to each other. n 2 times k is also equal to 2j plus 1. Now what's wrong with that? Well, let's get the constant 1 all by itself. And so 2 times k minus j is equal to 1. And so I can divide k minus j is equal to 1/2. Now this is where things go wrong. By the axioms of arithmetic, k minus j is an integer. If I take an integer minus an integer, that's an integer. But 1/2 is not an integer. And so there's my contradiction. And so now I use some kind of contradiction symbol to denote this. Here's a common contradiction symbol showing two arrows going against each other. My math teacher, when I was a student, taught me to draw a circle with a big X through it. That also works. Basically, some kind of symbol to say that we've reached a contradiction. Now, what did we contradict? We contradicted the assumption that n was odd. Therefore, n is not odd. And so that is the end of the proof. And so we use some kind of end of proof symbol to say that we've reached the end.